Assalamualaikum warahmatullahi wabarakatuh. Today, we like to present our group project, which is Clinic Locator. My name is Ahmad Firdaus Ahmad Khalid. So here is our table of content, which is we have the introduction, target user, context of the application, demonstration, and lastly the conclusion part. Okay, for the introduction part, firstly we choose the project 2 for our group assignment. That mean we need to make a mobile application that will show the nearest medical center or hospital or clinic, which is uh, our mobile application is designed for enhance the location tracking and emergency accessibility. It is for the our mobile app also have the main simple feature like the app have like login, and our app have the function to show the user position and also the nearby hospital and have clinic. So it can help for the user like solo traveler or the person who need to find a nearest hospital in fast way.
Okay, now we go to the next slide is target user. For target user, our application is designed for mobile user who rely on location-based healthcare information while moving between locations. The first target user the first target group is drivers, such as private car users or ride-hailing drivers. These users may need to locate the nearest hospital or clinic while traveling, especially when they are unfamiliar with the area. The second group is cyclists. Cyclists are generally more exposed to physical risk compared to other road users. In the event of an accident or injury, quick access to the nearby medical facilities is very important. The third group includes local residents and general mobile users, particularly those who are in unfamiliar areas or emergency situation. These users depend heavily on a mobile device to access real-time location-based healthcare information. Overall, these users are highly mobile, time-sensitive, and rely on real-time location data, which make them suitable for user for our application. The next slide is user characteristics and design implication. For the first is goal-oriented usage. Our users typically have a clear objective, which is to quickly find a nearby hospital or health clinics. Therefore, the application display the user's current location and the nearest healthcare markers immediately after login, eliminating unnecessary steps and reducing response time. Next, on-the-go interaction. Target users such as drivers and cyclists often use the application by moving or under time pressure. To support this, the application automatically detect the user GPS location and minimize manual input. Key information such as the maps, current location, and clinic marker is always visible on the screen. In terms of ease of use and simple navigation, the application is designed for users to varying technical backgrounds. We use clear labels, uh, intuitive icon, and large touch-friendly button. The navigation flow is straightforward with minimal screens, allowing user to use the app efficiently even when multitasking. Another important aspect is low cognitive load. In healthcare-related situations, users may feel stress or urgency. To address this, the application use a clean layout with minimal text and uncluttered interface. Only essential information such as location and nearby healthcare facilities is displayed. As a result, the overall design outcome is faster access to the healthcare information, reduced user errors, and safer, more efficient mobile usage.
Hi, I'm Muhammad Aziz Daniel. So now let's go to the context of the application. So these are the characteristics of mobile user. The first one is urgency and immediacy. So the constraint is mobile customers use apps urgently during medical emergencies. So that means the mobile user often open this app when they have urgency. So in this medical situation, every second is count. So what's the solution? Solution is the app loads the map and hospital markers automatically immediately after login. So uh, we focus on speed. The map and markers will load the moment authentication is done. So there's no loading screen or welcome tour to slow them down. So this really fulfill the urgency. So the second characteristic is context awareness. So the constraint is the mobile user physically move across different contexts. So unlike the desktop is only accessible from office or home, but in the mobile apps, it can be accessible even the users are moving. So the solution, we use device sensors to constantly update GPS position that shows only the health clinic nearest to the user's current location. And these are the characteristics of mobile devices. The first one is battery constraint. Constant GPS and network access consume large amounts of energy. So mobile devices has a limited battery. So when the mobile use GPS and network access, it will constantly make the battery phone die very quickly. So the solution is reduce data transmission. Only strictly important info like name, time, or GPS is sent to the server to preserve battery. So we avoid sending heavy images or videos to server to limit the usage of the phone battery. The second one is small screen size. The constraint is limited display size can cause cognitive overload if cluttered. So phone screens are very small. If we display too many hospital at once, the map will look like a mess and the user will be able to click anything. So the solution for this small screen size is we implement a limit to show that few hospital markers to ensure location are identifiable without excessive zooming. So there's a strict limit on it. The app only calculate the distance and only shows the nearest hospital to keep the interface clean and usable on a small screen. The third one is network requirement. The constraint is network connection is essential for sending user agent and location information. So our app is a client server application. It requires an active internet connection like mobile data or Wi-Fi to function because it needs to talk to the external database. So the solution is to ensure the web server side application can list reported position even while the user is moving. So even if the user is moving in a car, and the app keeps sending the data.
Assalamualaikum warahmatullahi wabarakatuh. So today I will demonstrate our app Clinic Locator, how the user can use it. So the first thing, user need to install the app Clinic Locator. This is our app. The icon logo, just click it, and the first page is login page. User need to enter their username and password. For this demonstration, I will use demo account here. Just type Ali, and the password is 1234, and click login, and login successful. Just click OK, and it will bring you to the dashboard. When the user login, it will save all the data of the user in the MySQL database. So in dashboard, it will show the user full name, username,
login time, and device. What Android version that user use and what the phone name that user use. So the main function of this app is to locate nearby hospital or clinic around you. So the user need to click here, open map, clinic or hospital. Just click, and it will open Google Maps. And just tap button here to locate your current location. So here I am at UiTM Machang. So here is the nearest hospital or clinic. Will show here clinic Sultan Bagul Judah around 2 and 06 km from here. Here it will mark as green marker, the nearest clinic. And there is other hospital or clinic that are marked around your location, such as here Klinik Sultan Bukit Bakar or Hospital Macang. And there is also around Tanah Merah. So here it will show the nearest hospital clinic around you. So we go back, and this is about section that will tell you about description of our app, and this is our all team members. The program course and the copyright sentence, and the lastly reference URL to the GitHub page. Just tap it, and it will open GitHub page that you can see all the code that used to develop this app, the description of the app, technology used, and lastly you can download the app in the release page. Download the APK of the app. So we go back, and lastly we log out. User can log out. Just tap log out button and click log out confirmation. And that's all for this demonstration. We just close the app, and that's all. Thank you.
So for the conclusion, our project successful to develop the application that will enhance the personal safety emergency access and design the protest mobile characteristic that ensure the efficient of interaction for the target like driver, cyclist, or solo traveler. So it will help to optimize the battery usage and limiting map marker to fit the small screen. And lastly, the system integrate the secure routing, real-time tracking, and step mapping to provide a reliable solution for remote monitoring and emergency response. Okay, that's all for our presentation. Thank you for listening.